Hey, welcome back to Mr. PLs with Precal. This is Unit 3, Topic 1, and we are doing our intro to trigonometry. So you probably have heard SOHCAHTOA. SOHCAHTOA is just for the basic trig functions. Sine of theta is opposite over hypotenuse, so it's really just a way of remembering them. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So this is adjacent over hypotenuse, and this is opposite over adjacent. All right, so now, depending on which angle you're using, the opposite and adjacent sides are going to be different. So if I use sine of angle C, that's this angle, which means the opposite one is the one that's across from it. And the adjacent one is the one that is next to it. And then this will always be the hypotenuse because the hypotenuse is always the longest side. So sine of angle C would be 8 over 10. Now, yes, that can be simplified, which I'll do in the next couple of examples. Cosine of C would be adjacent over hypotenuse, which would be 6 over 10, or 3/5, or 3 over 5. Tangent of C would be 8 over 6. Sine of M, now we're talking about the opposite angle. Now if this is theta right here, this is what we're looking for, then the opposite of it would be the 6. So things have switched, the 6 and 8 have switched. Now the 8 is adjacent to it, it's next to it because it's actually touching this angle, and then the opposite side is over here. So sine of that would be now 6 over 10. Yes, these are the same thing. Same thing with these. These are going to be the same thing. Adjacent over hypotenuse would be 8 over 10. And then the opposite is now 6, so it's now 6 over 8 instead of 8 over 6. All right, so now we are going to talk about reciprocal of the trig function. So the reciprocal means it's been flipped. So cosecant is the reciprocal of sine. So this is going to be hypotenuse over opposite. And secant is the reciprocal of cosine. So this is hypotenuse over adjacent. And cotangent is the reciprocal of tangent. So that's adjacent over opposite. So the way you can find a missing angle is by using Pythagorean's theorem. So that's a squared plus b squared equals c squared. This only works when it's a right triangle. So this, so you do 12 squared, which is 144, and 16 squared, which is 256. And then if you add these two together, you get 400. And the square root of 400 is 20. So 12, 16, 20. This happens to be a 3, 4, 5 triangle. Now, I say 3, 4, 5 because this is 3, this is 4, this is 5, times 4, times 4, times 4. It's proportionally the same thing as a 3, 4, 5 triangle. All right, so sine of theta. So it tells you theta right here, so that's 12 over 20. Cosine would be 16 over 20. Tangent would be 12 over 16. And then the reciprocals are basically going to be the same thing switched. And then 16 over 12. All right. Suppose that I tell you that sine of theta is 3/7. Now, if this is theta, and then that means that this opposite is 3, and this hypotenuse is 7. So the first thing I'm going to use is Pythagorean theorem in order to solve for the missing side. So this is 9 plus b squared equals 49. Subtract 9 from both sides, you get b squared equals 40, and then square root of both sides means that this side happens to be square root of 40. All right, so now a couple things you want to keep in mind here is that, well, first of all, square root of 40 can be simplified because a perfect square of 4 goes into 40 perfectly. So square root of 40 is like square root of 4 times square root of 10 because when you have two radicals multiplied by each other, you would multiply the two numbers on the inside. And then square root of 4 becomes 2, so it's 2 times the square root of 10. That's only if you use the positive root, of course, because square root of 4 is actually positive and negative 2. So that would become this. So I'm going to use this for this adjacent side. So sine of theta would be 3 over 7. Cosine would be 2 times the square root of 10 over 7. And then tangent would be opposite over adjacent, so that's 3 over 2 times the square root of 10. Now, to radicalize this, because you're not supposed to have radicals in the denominator of an answer, so I'm going to multiply this by 1. And I say 1 because anything divided by itself is 1. So I'm multiplying this by square root of 10 over square root of 10 because I want to get rid of square root of 10. So whatever this is in the radical, that's what I'm going to use to multiply top and bottom by. Because square root of 10 times square root of 10 is square root of 100, and square root of 100 is 10. So 10 times the 2 that was already there makes 20. And then the top becomes 3 times the square root of 10, and now I don't have a radical in the denominator anymore. All right, so cosecant, what's 7/3? It's pretty easy. Secant is going to be, all right, so now if I flip this, it'll no longer, so if I go 7 over 2 times the square root of 10, then I'll have to multiply both sides by square root of 10. Let me move myself out of the way. So that becomes 10. 10 times 2 is 20. 7 times the square root of 10. And that becomes the answer. Now, 7 and 20 can't be simplified, but if it could, you can simplify it just like a normal fraction. Now I'm not gonna flip this one, because if I flip this one, it's gonna be not the way I want. I want it to have a radical on the top, not the bottom. So I'm gonna flip this one. So it's 2 times the square root of 10 over 3, and that's my answer. All right, so next we basically have the exact same thing. I'm going to make this theta. You can make whichever side you want theta, but this has to be a right angle. Cosine of theta, which means that's adjacent over hypotenuse. So 5 squared is 25, plus something squared equals 64. Subtract 25 from both sides, and you get 39. So this becomes square root of 39. All right, so now that I've got all 3 sides, now I can write all 6 trig functions. So opposite, square root of 39 over 8. Cosine would be 5 over 8. Tangent would be square root of 39 over 5. Now, when I flip these, I'm going to get 8 over square root of 39, which doesn't work, so I need to multiply, and that gives me 8 times the square root of 39 over 39. Secant, if I flip this, becomes 8 over 5, and cotangent, if I flip this, becomes 5 over square root of 31. Multiply both top and bottom by square root of 31, you get 5 times square root of 31 over 31. This cannot be simplified. All right, so on to this question. Same thing, I'm going to draw my triangle. I'm going to pick a side. This is your right triangle. I'm going to pick a side to be my theta. It's cotangent. So now cotangent is adjacent over opposite. So that would be 5 over 12. And then I'm trying to find the hypotenuse. Because remember, tangent is opposite over adjacent, so this is adjacent over opposite. All right, so that's 144 plus 25 equals c squared. That adds up to 169, and the square root of that is 13. Now I've got all 3 sides. Sine is 12 over 13. Cosine would be 5 over 13. Tangent is 12 over 5. Now, no square roots in this, so I can just flip it with ease, and I'm done. 5 over 12. All right. Oops, wrong button. Okay, so in trigonometry, we're studying circular angles. Okay, so if this point right here is at 8, 6, then this is 8 and this is 6, so it's going to create a right triangle. Because remember, trigonometry is all about right triangles, but we don't know what this hypotenuse is. But they did give us the equation. If you remember back in geometry, it's always x squared plus y squared equals the radius squared. So if this is 100, that means the radius must have been 10. And once again, this is a 3, 4, 5 triangle. 3 times 2, 4 times 2, 5 times 2. All right, so now I can do the trig functions just like I would have before. So now we know theta is always the angle between the x-axis and the terminating ray. So whenever you have, it always goes counterclockwise starting from the x-axis in the right-hand position. Sine, 6 over 10, which is 3 over 5 technically. Cosine is 8 over 10, which is actually 4 over 5. Tangent would be 6 over 8, which is 3 over 4. And then flip them. So this becomes 5 over 3, 5 over 4, and 4 over 3. Remember, these are ratios, so don't change these to improper fractions. Or I'm sorry, these are, don't simplify them. I mean, simplify them like a fraction, but don't change them to a mixed number. Therefore, we will refer to these ratios in terms of x, y, and r. So sine is opposite over radius. Well, that's always the y, and that's always the r. So that's y over r. Cosine is adjacent over the radius, so that's x over r. And then tangent is y over x. And then, of course, these are going to be exactly the opposite, and that's x over y. And I'm at 10 minutes. I'm good on time. Okay, so what does it mean when we say the terminal side? So the terminal side is where the angle ends. So if we start right here on the right-hand side on the x-axis, like I said, the terminal side or terminal ray is where it ends, whereas the initial ray is where it began. So use trig ratios, you need to have a this is called a reference angle. A reference angle is an angle that is created from the x-axis to the terminal side. But it always goes to the closest x-axis, which means that the reference angle is always going to be an acute angle. Now, it doesn't matter which quadrant you're going to end up going into. So this is -4, and now I'm not really using the box, and this will be 3. Okay, this is a 3, 4, 5 triangle. Don't really need to use Pythagorean theorem. Knowing that, I can then write all the 6 trig functions. So sine, this would be theta, because remember, this is the reference angle. So that would be, sine would be 3 over 5. Cosine would be -4 over 5. And tangent would be 3 over -4. Now, of course, you would just flip them for the other 3 trig functions. Do this time. I'm going to just move on to the next one. So -12, -5 makes this angle. So 512, so let's say you don't know that, so that's 144 plus 25. The radius is always positive length. Now, square root of a number can be positive or negative, but we always use the principal root. Because length can always be positive. Now, I know you're thinking the left and right and up and down can also, how can they be negative? Because those are directions on the coordinate graph, whereas the hypotenuse is just simply a length from the origin to the point that you have chosen. So that adds up to 169 equals c squared, which is 13. 5, 12, 13 is one of those Pythagorean triplets, probably the second most common one that you'll ever see. And then, let's see, sine of theta would be -5 over 13. Cosine would be -12 over 13. And tangent would be -5 over -12, which is +5 over +12, technically. All right, so 2 this way, 3 this way. 2 squared is 4, 3 squared is 9. And add those together, you get 13. So this becomes square root of 13. So sine would be 3 over square root of 13, which, you know, once again, can be radicalized to 3 times the square root of 13 over 13. Cosine would be 2 over square root of 13, which once again would be 2 times square root of 13 over 13. And tangent would be 3 over 2. All right, and I made it in the time limit. Thanks again for watching, and I'll be making quite a bit more videos. Thanks again. Please give it a like to help you learn something about the basic things when it comes to trigonometry. Have a great day.